My name is Mr.Adebanjo. Today I'll be teaching us property of a circle. And why property of a circle? Because with the few experience I've had so far in uh, teaching, I discovered that students tend to have difficulties in circle maturation and circle geometry, and that's why I took it upon myself to help them a lot. And the reason why they have these difficulties is that because they have failed to understand the properties of a circle. And that's why I'm trying to explain it to them right now. And we can now extend it to the other topics. So as you can see on my screen right now, you have a circle, and a circle is the locus of points with equal distance from a fixed point. When you have a locus of points with equal distance from a fixed point, you have a circle, as you can see on the screen. The first property we're talking about today is circumference. And circumference is a part around a circle. This part, as you can see, is named circumference of a circle. The part around a circle is called a circumference. Next one is the radius of a circle. A radius is a line that is drawn from the center of a circle to a point on the circumference. A line drawn from the center of a circle to the point on the circumference. As you can see, line AO here is a radius of the other circle. A line drawn from the center to a point on the circumference is called a radius. Now we are on this one. Now we are having three radius on this circle. We are having radius AO, radius OB, and radius OC. One thing about radius of a circle is that they are all the same thing. If AO is 2 centimeter, OB is also 2 centimeter, and OC is also 2 centimeter. The radius of any circle is the radius of a circle are almost the same. Of a specific circle are almost the same thing. So you can see you have three radius on this circle now. The next one, you're having diameter. A diameter is a line which passes through the center of a circle and touches the circumference at 2 points. You can see this line AB is a diameter, and it passes through the center O of the circle and touches the circumference at point A and point B. So that is a diameter. And a diameter will give us 2 radii. And to get from radius also, you can get diameter by multiplying the radius by 2, give us the diameter. And from the radius, you can get diameter as well by multiplying the radius by 2. You get diameter, and from the diameter can get radius by dividing by the diameter by 2, give us the radius. And you can see on the screen now, line AB is a diameter. Now the next one property is a chord. A chord is a line which touches the circumference of a circle at 2 points. A line that touches the circumference of a circle at 2 points, at point A and point B, the line touches the circumference. But the difference between a chord and a diameter is that diameter passes through the center, but a chord do not pass through the center of a circle. It does not pass through the center of a circle, but a diameter does. So line AB here is a chord rather. Line AB is a diameter. Then we have a lot of diameter. So line AB rather is a chord rather. Sorry. On here also we have a lot of chords here. You can see on the screen. Line AE is a chord. BH is a chord. FC is a chord. GD is also a chord. Now the first question you have to attempt for me, after you might have gone through this training, is by with OB the center of the circle here. You have to you have to list how many radius, diameter, and chord we have in this circle above, and name them accordingly, and drop them in my comment section on YouTube so that I can attend to them. How many radius, diameter, and chord do we have in this circle above? The same thing here in the second question 2 as well. You have to name radius, diameter, and chord we have in the circle above, and list them and name them, and drop them in my comment section on the YouTube channel. And do subscribe to my YouTube channel for more videos. And after this video, now we'll be talking about midpoint theorem. And I hope you have learned 1 or 2 things in this short video. Thank you, and God bless you. Mr. Adebanjo. Today I'll be teaching us our midpoint theorem. And in our last class, we talked about the properties of circle. And if you have not watched the property of circle, please go there and watch it now. because that's what will help you understand this midpoint theorem. Please go back to circle of part of circle if you have not done so. We can talk about the midpoint theorem. The midpoint theorem is one of the theorems you have to know before you go to circle geometry, and there are three of them, and we are going to quickly talk about them very briefly. And then in the next video, we'll talk about how you can use them to solve problems. The first theorem says that a straight line drawn from the center of a circle to the middle point of a chord is at a right angle. As you can see now in this circle now, we are having radius AO, radius OB, and a chord AB. So a line is drawn from the center O to point C here, which is the middle of the chord AB. So the theorem is saying that the angle that is formed here is angle 90 degrees. That is when you draw a line from the center of a circle to the middle of a chord, then the angle that's going to be formed there is going to be angle 90 degrees. And from what you can see from triangle BOC, the angle at C here is 90 degrees. Also from triangle AOC as well, the angle here is also 90 degrees. That's the first theorem. The second theorem is like that, says that a straight line drawn from the center of a circle perpendicular to a chord bisect the chord. As you can see here that the line here drawn from this center of the circle O here to this point C, we bisect this chord AB into two equal halves. That is, AC is going to be equal to CB. That's what the theorem is talking about. That the line that is drawn from the center of the circle to bisect a chord is going to cut the chord into two equal halves. That is, AC is going to be equal to CB. That's the second theorem. Also, the third theorem says that the equal chord of a circle are equidistant from the center of the circle. That is, when you are having two chords in a circle and they are equal in length, that is AD is equal to chord BC. That means they will have equal distance from the center of the circle. The center of the circle is O. That means the distance OM is going to be equal to the distance ON. That's what the theorem is talking about. Another way is that when you are having two chords in a circle and they are having equal distance from the center of the circle, that is your OM is equal to ON. That means the two chords are equal in length. That's another way you can view it. That when you're having two chords in a circle and they are of the same length, that means their distances from the center of the circle are the same thing. And that's what the theorem is talking about. And you can see, if I wrote here, if chord AD is equal to BC, it means that OM, which OM line AOM is equal to what? Line ON. That's what it implies, and vice versa. That is, if ON is equal to OM, it means that the chord BC is equal to chord AD. These three theorems we are going to be using to solve problems in the next video. And please, if you have not watched the previous video on the property of circle, do so. And if you understand this, I'm not here to prove the theorem for us. I'm just here I'm here to help us to understand the theorem and use them to solve problems. So in the next video, we'll be solving problems on this midpoint theorem. Do like the video, subscribe on my channels for more videos, and share the video. Put down your comment if you like the videos and under the video. And thank you for listening. Have a wonderful day. And today we'll be talking about we'll be solving some problems on the midpoint theorem. In our last video, we talked about the theorems, three of them, and if you have not watched the theorem, please go back to the video I made on the midpoint theorem, part 1. And before you can now watch this video, because here we are going to be solving some problems using the theorem we have learned in the past. The question you're having here on the board says that a chord of a circle is 32 centimeters long. The distance of the chord to the center of the circle is 12 centimeters. Question number A, calculate the radius of the circle. B, calculate also the length of a chord, which is 14 centimeters from the center of the circle. And you can see on the screen, this is the pictorial representation of the question you're having there. You're having a chord 32 centimeters long, and you're having a chord AB here, which represent that chord 32 centimeters long, because in the previous theorem with length, that when a line is drawn from the center of the circle to a chord, is going to bisect that chord into two equal halves. That's why you're having 16 here. If you divide by your 32 by 2, you'll be having 16 centimeters, 6 centimeters here. Then from there, you are told that the distance of the chord from the center is 12 centimeter, and that's why you're having this line to be 12 centimeter. If I should draw a line from the center of the circle to this chord here at the circumference, point A here, you'll be having this line AO to be a radius. And if that should be the case, from the triangle AOC, you can calculate the length of that radius. And that's what you're having here. And then I said from triangle AOC using Pythagoras theorem. If you formulate your Pythagoras theorem is saying that the square of the hypotenuse sides is equal to the sum of the square of the remaining two sides. And that's what you're having here. Then you have your AC to be 16 centimeter and AOC to be 12 centimeters squared. If you square both of them, you'll be having 256 plus 144 equal to 400. And if you find your HO by finding the square root of the 400, you have 20 centimeters. That means the radius of this circle is 20 centimeters. So the radius of the circle at any point of is what 20 centimeters. And that means you have been able to solve the question number A there. Then question number B says that or calculate the length of the chord which is 14 centimeters from the center of the circle. That means there's another chord in that circle, and we have to calculate the length of it. So that's why I have chord XY here. So and we are told that it's 14 centimeters from the center of the circle. That means from O to this chord here is 14 centimeters. And also you can see that this line is going to form an angle 90 with this chord because of the last theorem we talked about the last time. And you can also draw a radius to this chord at point X to the center of the circle, which is going to form a right angle triangle as well. So we know that our radius AO here is 20 centimeters. That means this SO is also a radius. So it's also going to be 20 centimeters. And that's what you're having here, that OS is equal to OAO, which is 20 centimeters. The reason is radius of the circle. So from the triangle ASOZ, we can find our XZ using Pythagoras theorem as well. Since we know this side and this side, then we can use Pythagoras to find our XY, so XZ rather, which is going to give us 14.2 centimeters. And so since we know that from the theorem we learned in the past that our XZ here is going to be equal to XY, our aim is to get the length of the chord, which is XY. So if you multiply XZ by 2, or you add XZ plus XY together, which is at the same thing, that means you'll be having 28.56 at this length of that chord. So that's the solution to that question. More questions is still coming in the next video. So if you like the video, please do subscribe to my YouTube channel, like the video, comment on it, and share it with your friends. And in the next video, we'll still be solving another question on midpoint theorem. Thank you for watching the video. Have a wonderful day. If you please, if you are trying to find it confusing, review the video and you understand. Thank you. This question, now we can solve this question, which is related to midpoint theorem. The question says that PQ is a chord of a circle. The radius of the circle is 10 centimeters, and the distance of the midpoint of the chord from the center of the circle is 6 centimeters. Calculate the length of the chord PQ. Calculate the angle chord PQ subtend at the center of the circle. In our last class, we solved this question, and I believe it's understandable. And in this class now, we're solving this problem. And if you can see, this is the pictorial representation of the question. We're having chord PQ, as you can see, PQ, and the radius of the circle is 10 centimeter. PO is the radius. That's why I have 10 centimeter there. And in the last class, we're not given the radius. We found the radius ourselves when we were given the length of the chord. In this case, we are not given the length of the chord. We have to look for it. And you can see we are given the distance of the chord from the center, which is 6 centimeters. And that's what you can see on the diagram. So if you draw it correctly as I have drawn my own, then you'll be having this radius 10 centimeter and the distance of the chord from the center to be 6 centimeter. That would give us a right angle triangle here. And from the diagram I have here, OP is 10 centimeter, ON is 6 centimeters. You can see from the triangle PON, you can use Pythagoras theorem to find our PN here, and that's what you're having here. say Pythagoras theorem says that whole p square equals to pn square plus on square. Then from there, you can make a pn square instead of formula, and that means you'll be having 100 minus 36 equal to 64. To get our pn, find the square root of 64, give us 8 centimeters. Therefore, our pn is 8 centimeters. But in our previous theorem, we know that this n is the midpoint of this of the chord PQ. So that means Pn is equal to NQ. So to know the PQ, this one PQ now, or the length of the chord, that means you have Pn times 2 will give us the length of the chord PQ, and that will give us 16 centimeters. So also to find the angle that chord PQ subtend at the center, we can from the triangle, we can find this angle theta here. So the angle that this cause PQ subtend at the center is angle POQ, the total angle that is here, and that's why we represent by theta plus theta will give us that total angle there. So you can find this theta, which same thing as this theta as well. So when you add the two together, we give us the angle this cause subtend at the center. So how can we find this one? You can use any of the trigonometric ratio, whether sine, cos, tan, because you're having the three sides of this triangle given now. So when we have already find our Pn, so I use cos here, cos theta here, we give us 6/10, and that gives us 0.6. Then from there you can find our angle theta, which is inverse of inverse of cos, and that will give us 3.13 degrees. And to know the total angle here, which PQ subtend at the center, then that will give us this plus theta plus theta, and that will give us 153.13 plus 50.13, and that will give us 106.26 degrees. That's another question you can be asked of finding a midpoint theorem, finding the angle that the chord subtend at the center. So I hope you understand this question, and if you don't, please review start the video again and go through the solution and my voice or clip. You understand? Please do like the videos, subscribe to my channels for more video. In the next video, we'll be talking about circle geometry from the first principle, from the first theorem rather to the last theorem. And do stay tuned and like the video and share with your colleagues. And God bless you for watching. Another question on a midpoint theorem. In the last two videos, we talk about this. We have solved this question on midpoint theorem, and also this question as well. We solved this question as well. In this third video as well, we'll be solving this third question, and the question is still familiar. It's still on a midpoint theorem. If you look at the first question, here we are asked to find the radius and the length of another chord, this xy. In the second video, we are asked to find the length of the chord when we are given the radius. In the first one, we are not given the radius, but we are asked to find the radius given the chord. But here you are given the radius here, 10 centimeter. You are asked to find the length of the chord PQ. But if you look at this third question, you are given the chord of a circle is 12 centimeter long. The radius of the circle is 10 centimeter. You are given the length of the chord, and you are given the radius as well. You are asked to calculate the distance of the midpoint of the chord from the center of the circle. That is, we have to find the distance of this chord from the center, which is represented by this OM, this distance OM here. That's the distance of this chord from the center of the circle. So in this second question, we are now asked to do that we have been given, and that is 6 centimeter. In this one as well, we have been given, and that is 12 centimeter and 14 centimeter for the two chords. But in this third question now, we are asked to find the distance of the chord from the center of the circle, and which is our OM. Since we are given the radius, which is A or 12 centimeter, and we given the length of the chord to be 12 centimeter, with the midpoint theorem, one of the theorem says that this distance from the center will bisect this chord into 2. So if we divide this 12 by 2, we have 6 plus 6. So that because our AM is equal to our MB. So since that is that, well, we know the AO, which is the radius of the circle, and which is the same thing as our OB, because that's also a radius. So from the triangle AOM, AOM or AMO, that triangle now you have been given the hypotenuse side of it, and we have been given this AM. You can find that distance of the chord from the center of the circle, which is our OM. And that's what you are having here, that if you use from triangle MOA, if you use Pythagoras theorem is the square of this hypotenuse side AO squared equals to the sum of the remaining square of the remaining two sides, that is AM squared plus OM squared. And that's what you are having here. What's our AO? That is 10 centimeter, squared it. Then AM is 6 centimeters, squared it as well, plus OM, which is what you are looking for. Then make OM the square of the formula. You'll be having OM square equals to 100 squares, sorry, 10 squares 100, minus 6 squares 36. Then 100 minus 30 will give us 64. Then therefore you can find the square root of MO, so that you can get our MO. And that means you also find the square root of 64. That gives us 8 centimeters. That means the distance of this chord AB from the center of the circle, which is represented by this line AOM, is what? 8 centimeters. So that means this our OM is what? 8 centimeters. And that's the third question we have solved on midpoint theorem. So any question you are given on midpoint theorem, you just need to understand the question and the theorem that we have explained in the past. So that's the end of this question. In the next video, we'll be starting circuit geometry in full. So thank you for listening. Do subscribe to my YouTube channel, share the video with your colleagues, and like the video, and drop your comment under the comment section of this video. Thank you for. We talked about midpoint theorem and how we could use it to solve problems. But today we'll be talking about circle geometry or circle theorem. And the first theorem we're talking about today, we are going to need this theorem on the screen now to prove the theorem. The theorem says that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Exterior angle is the angle outside the plane shape, while the interior angle are the angles inside the plane shape. That is, the addition of these two angles is equal to this angle that is here. So we are going to need this to prove that theorem we're going to talk about very soon. And also we are going to need this theorem as well that says the base angle of an isosceles triangle are equal, to prove the theorem we want to talk about. And this is the theorem we want to talk about now. The first theorem in circle geometry says that the angle and arc of a circle subtend at the center is twice the angle which is subtend at any point on the remaining part of the circumference. That is this arc AB here and this arc AB as well. The angle is subtend at the center is twice the angle is subtend at the circumference. That is angle AOB here. This total angle that is here is twice the angle that is at the circumference, like this. The same thing here, the angle that is here is twice the angle at the circumference. And this proving is applicable to these two circles. And let's go through it. If you look at this triangle APQ, it's an isosceles triangle. Why? Because AO is a radius and OP is also a radius. So that means those two sides are equal. And from the theorem we saw before, that means this x1 and s2 are the same thing. They are equal. And that's what you are having here, that they are equal. So from that triangle, you can get this angle AOQ, this angle outside the triangle, this angle here, by adding this s1 and s2 together. And the reason is exterior angle of a triangle is equal to the sum of the opposite interior angle. And that's what we saw the other time. So that means this angle here is going to be x1 plus s2. But we said that s1 is equal to s2. So that means you can replace that s1 with s2. That means we'll be having s2 plus s2 here. That will give us 2s2. And that's why this angle AOQ is 2s2. If you do the same thing to this triangle, triangle BPQ, this other triangle here, the same triangle is applicable. This OP is equal to OB, then because they are radii, so that means the y1 is equal to y2. So that means this angle here is an exterior angle to this triangle. So it's going to be addition of this y1 and y2, and we give out this one. But our y2 is also y1 as well. So you can regard this angle BOQ, this angle here, as s2 plus s2. That will give us 2s2. So the addition of this angle that is here is going to be the total angle here is going to be addition of this angle and this angle here. So, and that means you'll be having 2s2 plus 2y2, and that's what you are having here. We said our AOB is addition of this angle plus this angle, and that's what you are having here. Then you are having 2s2 plus 2y2. If you factorize 2 out there, you'll be having 2
into s2 plus 2 into s2 plus y2. Then you know that this angle p here at the circumference here is addition of this s2 plus y2, and that's what we have here, that 2 in times this angle APB, that is this angle here, is going to be s2 plus y2. So that means this angle here, total angle here at the center here, is twice the angle that is here, and the same thing is applicable to this circle as well, and that is the proving of the first theorem of that says that the angle at the center is twice the angle at the circumference. And we'll be using that to solve problem in the next video. If it is not labeled, but we are having an angle at the center here, which this arc of thread at the center is x. The one so that the circumference here is 41 degrees. You have to find that angle x. So you can see that x is 2 times 41 degrees. That is, this angle here is twice the angle that is at the circumference, and our x is 82 degrees. And the reason being that, don't forget that anytime you are talking about circle geometry or anything involving angle, you must always give the reason why the answer is like that. And the reason why this angle is 82 degrees is because the angle at the center is twice the angle at the circumference. And that one is very simple to do. Let's move to the next question. If you look at the second question you're having here also, we are giving this angle at the circumference here as 135 degrees. We have to find angle T and angle U. And if you look at the solution, angle T here is going to be twice of this angle at the circumference. And that we're having here, that T is 2 times 135 degrees. The reason being that angle at the center is twice the angle at the circumference, and angle T is 270 degrees. Having gotten our T, we know that angle T here and this angle U here, the addition of the two of them will give us 360 degrees. Why? Angle at a point, or some people will say that angle in a circle, no problem. But this is angle at a point. So U plus T will give us 360 angle at a point. We already know our T to be 270 plus U equals 360. Then from there you can find your U to be 90 degrees. That's another question under the theorem we talk about. Angle at the center is twice the angle at the circumference. The third question we're talking about today is this question you can see on the screen. Here now we are having three unknown here, x, y, z. And you are giving this angle at the circumference as 119 degrees. So if I ask you which of the angle do you think you are going to find first, the answer is you're going to find this x first, because this angle x here is twice the angle at the circumference here. So if you find that, that will give us 238. The reason being the angle at the center is twice the angle at the circumference. From there, you cannot find your y, because the addition of s and y will give us 360 degrees. And that's what you're having here. And then you can find your y to be 112 degrees. And then we know that this angle here, y here, is twice the angle at the circumference here. Look at the difference. So the angle here is twice the one that is up here, and the one that is here is twice the one at the down here. That's the difference. Please take note of that difference. It's very important. Look at the way it is drawn. This x is twice the angle of twice this 119, and this y is twice what z. So to get our z now is by dividing this our y by 2, we give us what is z, and that's why our z is 61 degrees. So that's the solution. In the next video, we'll be talking solving more questions on the theory about now is the one on the screen right now. And the question says we are giving this circle, and we look at the diagram very well. We are giving this angle as 21 degrees, angle W, and this angle 90 degrees. We are having x, y, z as the unknown that are there, and W. We have to find all this unknown, and this is the solution right here beside it. If you look at the triangle here, you are having a right angle triangle here, and that's not that, but we are giving two. We already know the two angles of that triangle. Look, we can find the third angle, which is W, and that's what we're having here. 21 degrees plus W plus 90 will give us 180 degrees. The reason being that sum of angles in a triangle, and then from down, if you add this together, you have 111 degrees plus W equals 180, and from there you can find your angle W, which is 69 degrees. Now, from what you have learned in the previous video, there's a relation between this angle W and angle X here, not angle Y. There's a relation between this angle W and angle X, because angle X is twice the angle W. So if our angle W is 69 degrees, that means to get our X, you have 69 times 2, give us X. And now you're having X to be 2 times 69, that will 138 degrees. The reason being the angle at the center is twice the angle at the circumference. And also, we also know that our angle S here plus angle Y here will give us 360 degrees. The reason being that this is angle at a point. So, and that's what we're having here. Our S is 138 plus Y equals 360 degrees. And from here, you can find our Y to be equal to 222 degrees. And we know also that there's a relation between this angle y and angle z. The reason being that angle y is twice this angle z, not angle x. Angle y is twice the angle z. So if you know our y to be 222, then to get our z, what do? Divide y by 2 will give us our angle z, which is 111 degree. The reason being that angle at the center is twice the angle at the circumference. That's solution to that question. The next question you're having here on the screen is also very simple as well, using the theorem we have learned. Look at it. You are looking for angle ABCD, giving this angle 43 degrees. But if you look at the previous the plane geometry, you know that there's a relation between this angle 43 and this angle A. This angle A and angle 43 degrees are the same thing, they are equal. So that I have A to be equal to 43. Reason being that they are vertically opposite angles. Also, if you look at this triangle here, because this side here is equal to this side here because they are both radius. So that means this triangle is an isosceles triangle, and base angle as well as triangle are equal. That means our B is also what equals to A. That's why we 43 degrees. So from there, you can use that to find our angle C. Sum of angle in a triangle is 180. Then you can get your C using that to be what 94 degrees. Then from there, now we know that there's a relation between this angle C and angle D. This angle C is twice the angle at the circumference. That we're having our D to be equal to half of 94, that will give 47 degrees. Angle at the center is twice the angle at the circumference. That's another solution to another problem. So in the next video, you're having some question you have to solve on your own to try whether you have you understand this theorem or not. So in the next video, we're talking about the next theorem on circle geometry, and we used to solve problem as well. Thank you.
My name is Mr. Adebanjo. In our last class, we talked about the first theorem in circle geometry that says that the angle and arc obtained at the center is twice the one that is obtained at the circumference. And we use this theorem to solve problem. So in today's lecture, we'll be talking about the second theorem in circle theorem that says that the angle in the same segments are equal, as you can see on the screen right now. And we are having these two angles at the circumference, x1 and s2. I'm saying that these two angles are equal, that is s1 is equal to s2. And the proving is what we have beside it, the diagram. It's saying that this angle AOB is twice this angle x1, which is what we proved the last time we talked about angle at the center is twice the angle at the circumference. So this angle AOB is twice this angle s1. Also, this angle AOB is also twice the angle s2. So if that's the case, and that's what you're having in this problem, with the lettering in the figure, angle AOB is 2 times x1. The reason being that the angle at the center is twice angle at circumference, and the angle AOB is also 2 times angle s2. The same reason, angle at the center is twice the angle at the circumference. So which means that our s1 is and s2 are equal because they are both half of the angle AOB. So it means that the angle s1 is equal to angle s2. And I want you to take note of one thing, that the leg of this angle, look at this chord AP and this chord PB. It has the same leg with this chord AQ and chord QB. And that is why these two angles are the same, because they are in the same segment. They are in the same segment. That is, this angle in the same segment are equal. S1 is equal to S2. The second theorem we're talking about today also is the angle in a semicircle is a right angle. Angles in a semicircle is a right angle. What do we mean by a semicircle? You know that when we have a semicircle, when there is a chord in a circle, when a chord is included in a circle, that means we have a semicircle. Now, if you look at this chord, now you're having chord AOB here now, chord AOB, and look at this. Sorry, we are having diameter AOB rather. We have a semicircle when there is a diameter in a circle. Pardon me for that mistake. We have a semicircle when we have a diameter in a circle. Now look at this diameter AOB, and a chord is attached to it or joined to it called AX and called XB. Where these two chords meet, an angle is formed there at the circumference, and that angle is what we are talking about, and that angle is at 90 degrees.
So this is the proving, and that this angle here, this angle AXB is 90 degrees, because the angle and arc subtended at the center is twice the angle at the circumference. That is, this angle AOB here, this angle here, the one down, is 180 degrees, because the angle on a straight line is 180 degrees. So if this one is 180 degrees, then the angle here is twice the angle that is here. So if this one is 180, that means this one is going to be what, 90, and that's what all about this proving. So, and that's the reason why this angle at the circumference is 90 degrees. So we'll be using these two theorems that we just talked about to solve some problem in the next video. Use them to solve some problems and see how we can go about it. Don't forget, we talk about the angle in the same segment are equal, and that's the first this theorem. And the angle in the semicircle is a right angle. So we'll be using these two theorems to solve problem very soon. Thank you for watching. Hello viewers. My name is Mr.Adebanjo. In the last video, we talked about the proving of angle in the same segments are equal, and that's what you are seeing on the screen presently. And the second slide is talking about the angles in the semicircle is a right angle, and we proved these two theorems in the last video. So we are going to be using these two theorems to solve some problems in this video. The first problem we'll be talking about is the one you are having presently on the screen. That's saying in the diagram, PQ is a diameter of a circle, PMQN, center hole. That means this center hole here is the center of the circle, and the PQ, this line PQ is a diameter. Since it passes through the center of the circle, that means a diameter truly. So we are told that angle PQM, that is this angle I marked there, is 63 degrees. Find angle QNM. QNM, that is the angle marked there. So that we also find. And if you look at how can we find that that angle, we also find. If you look at this triangle QPN, from the theorem that we proved there in the last video, that says that angle at this in a semicircle is a right angle. Look at it, this is a diameter now. That makes this circle here a semicircle. Look at this line PQM and this line MQ joined to it. These two chord QM and chord PM joined to this diameter. They meet at this angle here. That means this angle PMQ is 90 degrees, because of what we proved the last video. So that's why you're having that angle PMQ is equal to 90 degrees. The reason being that angle in a semicircle. Then if this angle here is 90 degrees, and you are be giving this one as 63 degrees, angle PQM, 60 degrees, then we can find this angle, this third angle in that triangle QPM. So then we can find this third angle, and that we are having here. I said this PQM, that is this angle here. Then this one plus this one will give us 180 degrees. The reason being that sum of angle in a triangle. Then we already have this one as 63 plus 90. Then if you add these together, we have 153. Even 153 from 180, that will give us this angle QPM, and that will give us 27 degrees. That means this angle QPM is 27 degrees. But that's not what you have to find. You have to find QNM. But you can see that there's a relationship between this angle, the one that I just found, this QPM, and this angle QNM. What's the relationship? What's the relationship there between them? They are in the same segment. That's the first theorem we proved in the first video, that the angle in the same segment are equal. That means this angle here and this angle, they are in the same segment. So that means this angle here is 27 degrees, and that's what we are seeing on the screen right now. Second question you are going to solve in this video, you have to find all these unknown in this circle. You have to find this unknown. You are having P, Q, R as the unknown there. You have to find them. Now this question is very simple. Now our angle Q is going to be 56 degrees, because they are in the same segment with this angle 56. Then our angle P as well is also 28 degrees because it's in the same segment with this angle as well. Then if you know our Q and we know our P, we can find our R because they are in a triangle. Sum of angle in a triangle is 180 degrees. So since we know our P and Q, then add everything together plus R, we'll be having 28 plus 56. That'll give us 84. Then remove your 84 from 180 degrees, and that'll give us 96 degrees. That means our R is 96 degrees. This one is quite simple if you look at it technically. Then if you go to the next question, we are to find our xy, angle x and y. Then you can see that the relationship between this angle 65 given to us and this angle x, if you see look closely, you discover that they are in the same segment. Then if that is in the same segment, you can look at this line here, this line that passes through the center of the circle. That's a diameter. And look at the line that is joined to this chord and this chord joined to it. That means this total angle is going to be here. What here? As I was saying, if you look at this line, this line that you can see that I'm lighting on is a diameter because it passes through the center of the circle. So if you look at this line that is joined to this chord and this other chord joined to that diameter, that means this angle here, the total angle s plus y, will give us 90 degrees because of our angle in a semicircle is a right angle. So that means s plus y will give us 90. But you can see that there's a relationship between this angle 65 degrees and angle x. What's the relationship, if you can guess? They are in the same segment. So angle here is also 65 degrees because angle in the same segment are equal. So if s is 65 degrees, then we can find our y because s plus y will give us 90. So if you remove your 65 from 90, that will give us y, and that's why our y is 25 degrees. So the next question, we are having this diagram on the screen right now. We are having this angle H, we have to look for that, angle B to look for that, and we have to look for angle C, given angle 40 degrees and angle 32 degrees. Now, this one is also very simple. There's a relation between angle A, angle 40, and angle B. They are all in the same segment. That means angle A is 40 degrees, and angle B is also 40 degrees. If you look closely as well, you discover that there is this angle 32 degrees and angle C here. There is a relationship between them, and the relation is that they are also in the same segment. Look at the leg of this chord joined to this chord, then this, then this. You can see that there are relationship between them. They are in the same segment. That's what angle C is also 32 degrees. Then if you look at the next question we have it on the screen right now, we are having a lot of values to look for. But if you look at it closely, you discover that this angle T here and this angle 10 here, they have relationship. They are in the same segment. That's why our T is 10 degrees. And also, if you turn your book very well, discover that this angle 60 degrees and our angle U here, they have relationship 60 degrees. Angle U is also 60 degrees because they are in the same segment. Also, if you look closely as well, this angle 40 degrees and angle V, there is relation between them. They are also in the same segment. So V is also what? 40 degrees. Then if that is the case now, if you look at this triangle that I'm highlighting on this line, this one and this one, you already gotten our V, you already gotten our U, you can find our R because some of all these angles in this triangle it must be equal to 90 degrees. And sorry, 180 degree rather. So we already gotten this, you can find our R. And that's what you're having here. You're having 10 degree plus V plus U plus R equals to 180 degrees. Sum of angle in a triangle. So you have 10 degree plus V is 40 degrees, U is 60 degrees plus R equals 180. Then if you add everything together, you have 110 plus R equals 180 degrees. And our R will be 70 degrees if you do that. So there's a relation between this our angle R and our angle S here. Our angle R and angle S, they are in the same segment. So that means S is also 70 degrees. And that's solution to that question as well. So the last question we'll be talking about today is what you're having on the board. Sorry, on the screen rather. Now, if you look at this line here, is a diameter because it passes through the center of the circle. So, and look at this line joined to it, and this line joined to it as well. They are both chords. So that means this angle that is forming angle B is going to be what? 90 degrees. Increasing angle in a semicircle is a right angle. So that means B is 90 degrees. Then if you have been given this angle in from this triangle that you can see, then we can find this third angle here, and that will be sum of angle in a triangle, which is equal to 180 degrees. So if that should be the case, now you can find our here to be 44 degrees if you look at it closely. Then you can see that this line and this line here, they are parallel. That's why you're having arrows on them. So, and you can see that this line, this diameter, we turn to something in a plane geometry. It turns to a line of transversal. A line of transversal is a line that cut across two parallel lines. So, and you know that you have different angles formed when the line of transversal cuts across two parallel lines. Some angles are alternate angles, some angles are corresponding angles, while some angles are opposite interior angles. But in this case now, you can see that there's a relation between this angle 56 and angle C because of these two parallel lines and this line of transversal. This angle 56 and angle C are alternate angles. So that means that's the reason why angle. So as I was saying in the last video, that this angle C and angle 56 they are alternate angles. So, and that's why our C is 56 degrees. And also, you can see also you can also tell us this angle I'm highlighting on. You can tell us the angle as well, because I believe you should know, because look at it, this is a diameter and this the chord, another chord joined together. So an angle is formed here from the one of the theorem that we proved last time. You should know what the answer is. And if you know, you can drop the comment. You can drop the answer in the comment section of this video. So now these are the questions for you to do on your own. If you have gone through these two theorems that we have talked about, and you have gone through the problem that we have solved together, then you should be able to solve these three questions on your own, so as to evaluate yourself that of course you have really now learned one or two things. If you look at this third question, this one under here, there is also is combination of the theorem the first theorem that we talk about, that the angle in the center is the angle of the circumference. You can use that to solve this question, and the one we just talked about now, you can use this to solve the remaining two questions. So you have to please visit other materials like your textbooks and for more questions. And if there's any question you want to ask me, you can send it you can drop it on the comment section of the video, and I'll respond. My name is Mr.Adebanjo, and I want to welcome you to today's video. In the last video, we talked about angle in the same segment are equal, and we also talked about angle in a semicircle is a right angle. And we use those two theorems to solve some problems. In today's video, we're going to be talking about another two theorems in circle geometry. Another two theorems in circle geometry. And the first one we'll be talking about is what you are seeing on the screen right now. The opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. Now, what do we mean by what is the meaning of cyclic quadrilateral? Cyclic quadrilateral now. We have a cyclic quadrilateral when you have four-sided plane shape inscribed inside a circle. When you have a four-sided plane shape, you can see this as I'm highlighting it on the screen right now. This four-sided shape that is inscribed inside the circle. And one thing I want you to take note is that you can see that all the four-sided plane shape, they are touching the circumference of that circle at a point. Look at it, also at here, and here as well. So we're talking about that when you have a cyclic quadrilateral, the opposite angle there are supplementary. What are supplementary angles? Supplementary angles are angles that add up to 180 degrees. That is, opposite angles of the cyclic quadrilaterals are supplementary. That is, this angle here and this angle here, when you add it together, will give us 180. And also this angle that is here and this angle that is here, when you add it up together, them together, is going to give us 180. And that's what you are going to be proving now, and we use it to solve problem in the future. How do we prove that this angle S plus Y will give us 180 degrees? If this angle here is Y, you know that in our first theorem, we prove that the angle at the center is twice the angle at the circumference. That means if this is Y, that means this angle here is what? 2Y. That's what you're having here. Angle BOD is 2Y. BOD, this angle here is 2Y. Reason being that angle at the center is twice the angle at the circumference. Also, if this angle here is x, that means this angle here, this reflex angle of BOD, this angle here is 2s. Reason being that angle at the center is twice the angle at the circumference as well. So if you add these two angles together, 2y plus 2x, that should give us 360. The reason being that angle at a point. So and that's what you're having here. 2x plus 2y give us 360. And if you factorize 2 out of this, now you have 2 into x plus y, and that will give us 360. Then if you divide both sides by 2, you have x plus y equal to 180 degrees. So it means that this angle x plus y will give us what? 180 degrees. And that's the proving of that theorem. So we're going to be using this in the future to solve problems that the opposite angles of a cyclic quadrilateral are supplementary. The next theorem we're talking about today is the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. This is a cyclic quadrilateral right now. We're having four-sided shape inside this circle, but this line now is extended out here now. That made this angle S2 exterior angle of this cyclic quadrilateral. Exterior angle are angle outside the plane shape, while interior angle are angle inside the plane shape. This angle here is interior, this is interior, this Y is interior, but S2 is exterior. You have to prove that this S2 is equal to what? X1. Interior angle is equal to opposite exterior angle, and that's what you are having here. But in our last theorem now, we just proved now, we know that this angle S1 plus angle Y here will give us 180 degrees. Reason being that opposite angles of a cyclic quadrilateral. We just proved that now. S1 plus Y will give us 180 degrees. Also, Y plus S2 will also give us 180 degrees because angle on a straight line. So if you subtract these two equations here, you'll be having this one will go, Y will minus Y will give us 0, 180 minus 180 will give us 0. So you'll be having X1 minus Y, S2 will give us 0. So from there, our S1 is equal to what? S2. And that's why this angle here and this angle what? Here, they are what? Equal. Exterior angle of a cyclic quadrilateral is equal to opposite interior angle of that cyclic quadrilateral. So if I have an exterior angle at this side now, that means this exterior angle here is going to be equal to this D here. And if I have an exterior angle here now, this D here, that means this angle, exterior angle here is going to be equal to what? The opposite interior angle of this B here. So that's the two theories we proved now. We're going to be using them to solve problem in the next video. Thank you for listening. And in the last video, we proved this theorem that the opposite angle of a cyclic quadrilateral are supplementary. And we also proved that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. We're going to be using these two theorems to solve problems now in this video. Now, the first question we're going to be solving is the one you are having on the screen right now. Our aim is to find this angle A and angle B. And as you can see, you are going to use the two theorems that we just proved now to solve the problem. You can see that there's a relation between this angle 76 degrees and angle B here. They are both opposite interior angle of a cyclic quadrilateral. Because this is a cyclic quadrilateral right now, you're having four-sided shape inside the circle. So that means 76 plus B will give us 180 degrees. From there, you can find our B to be equal to what? 180 minus 76, that will give us 104 degrees. So the reason being that opposite angles in a cyclic quadrilateral. And also our angle A here, there's a relation between this angle A and angle 122 degrees here. This is an exterior angle of this cyclic quadrilateral. And exterior angle of the cyclic quadrilateral is equal to opposite interior angle. That means A here is equal to what? 122 degrees. And that's the solution to that first question. The second question we're talking about is the one you are seeing on the screen right now. And you're having O here to be the center of the circle. And that means that makes this TQ a diameter. A diameter. So we have to find angle X here. That's what we have to find in the question. But you can see that if this TQ is a diameter, that means this line, this chord that is joined to it, and this chord that is joined to it here, that means this angle here, total angle here is what? 90 degrees. We proved that an angle in a semicircle is at right angle. That means this is angle P here. Everything at P here is 90 degrees. And now we are having here TPQ. TPQ is 90 degrees, angle in a semicircle. If that should be the case now, in what you just proved now, you can see that this angle 132 degrees and this angle P here, this small one here, angle TPR, this angle here, the acceleration between those two angles and this angle here, 132 degrees, and this angle here, raising opposite angles in a cyclic quadrilateral. Look at this line, 1, 2, 3, then 4. You can see now that's exactly collateral. So that means this angle here 132 degrees and the angle P here we had up to what 180 degrees. That's what you're having here. Opposite angle in the side collateral. From there you can find our angle TPR. So if you remove it from this one from 180, you have this angle here. And that way you have 180 minus 132 will give us angle TPR. And the angle TPR will give us what 48 degrees. If angle TPR is 48 degrees, but we know that total angle here, this angle here plus this angle here will give us 90 degrees. We have said that right from here. So if I know that this one is 48 and I can remove it from 48, I can move 48 from 90 to get this remaining angle here. And that's what we're having here, that angle RPQ will give us 90 degrees minus 48. Because from here to here, total angle here is 90 degrees. Move this one from 90 will give us this angle. And that will give us what 42 degrees. There's a relationship between this angle here, angle RPQ, this angle here, and the angle X you are looking for. They're in the same what? The same segment. And angle in the same segment are what? Are equal. So that's why angle X is what? 42 degrees. 42 degrees. Then the next question here you are having on the screen right now, you are told that angle CE here, this line CE is a diameter. Line C is a diameter because of this is the center of the circle. So if line C is a diameter, that means this angle here, total angle here, is going to be what? 90 degrees. Reason angle in a what? In a semicircle. Because look at this line CD and line ED joined together. Then they meet at this point. So that means this angle here is a what? It's 90 degrees. Angle in a what? In a semicircle. Also, you can see that there's a relation between this angle here, this angle D here, and this angle 127. There's a relation between angle ADC. There's a relation between this angle ADC, this angle here, and this angle 127. Because this line 1, 2, 3, then 4, this is cyclic quadrilateral now. I know that opposite angle in a cyclic quadrilateral are supplementary because they will add up to 180 degrees. So if I know that this one is 127 degrees, I can find this angle here, this one here, that is angle ADC. So that if I remove from this one from 180, that will give us this angle. And that's what we're having here, angle ADC. Where is ADC? ADC. This angle here is equal to 180 minus 127, and that gives us 53 degrees. These are opposite angles in the cyclic quadrilateral. So I've told you that this angle E, as I was saying that this angle, since angle EC since line EC is a diameter, that means the total angle here, this total angle here now is equal to what? 90 degrees, because angle in it was semicircle. And don't forget that the total angle here make up angle EDA and angle angle ADC rather. You're having two angles here that make up 90 degrees. So if that should be the case, now we have already found this angle ADC to be equal to what? 53 degrees. So if angle ADC is 53 degrees now, and total angle here is 90 degrees, so that we can find this small angle here. You understand? Now we can find angle AEDA. So if you remove 53 from 90 degrees, that will give us angle EDA. So that will give us what? Angle angle ADE. Angle ADE. So we give us 90 minus what? 53 degrees. And that will give us 37 degrees. So that means this angle here is 37 degrees. And the relationship between this angle here and the one we have to find, this one you have to find. What is the relationship? What is the relationship between this angle here, this one here, and this angle here? If you remember, they are both in the same segment, and that's why they are equal. The next question here, in question number 4, you have to find angle PQO. Angle PQO. This angle that is here, and given this angle here, this here, and there, you have to find this, and that is possible. There's a relation between this angle here and this angle here. You can find this angle PQ. You can find angle Q. You can find angle QPS. This one here, because this angle here plus this 77 will give us what? 180 degree angle in a straight line. So I remove this angle here from 180, I'll get this angle here, and now you're having that angle to be 108, 103 degrees. Also, the relationship between this angle here, this angle QPS, this angle here, and the angle here, angle at the center here, that's this angle QOS reflex. This one here The angle here is twice the angle that is here. Angle at the center is twice the angle at the circumference. So if this one is a 103, that means this one will be twice of it. And now you're having here that this angle QOS reflex, this the other one down, this one down, is going to be 2 times this angle, and that's what going to give us 206 degrees. Then if this angle here is 206, this angle here, the one down and the one up here, is going to the addition of them is going to give us 360 using angle at a point. So if I get this one as 206, I can find this one. So that will give us 360 minus what 206, and that's what we're having here. 360 minus 206 will give us 154. This angle here is 54. Now we have gotten this angle here and this angle here. We can find this angle because if you look at this line 1, 2, 3, 4. This is a quadrilateral. The total angle in a quadrilateral is 360 degrees. The quadrilateral is an example of quadrilateral is a square, rectangle. The total angle in a quadrilateral was 360. So if you have this angle, this angle, this angle, then you can find this one by adding this plus this, and remove it from 360 will give us this angle, and that's what we are having here. So therefore, our angle PQO is going to give us 35 degrees when you do that correctly, as you can see on the screen right now. Then the next question here is like the one we just solved now. Now we can find this angle here because there's a relation between this angle and this angle that is here. The angle at the center is twice the angle at the circumference. So this one is going to be half of this angle. So that's how you're having angle BAC rather. BAC, that is this angle here, to be half of this angle, 58 degrees. So if this is 58 degrees, then you can also find the reflex angle of this O, the other angle here, this reflex angle, by removing this one from 360 because this angle at the point. So if I remove 116 from 360, that will give me the angle that is here. So that will give us 244 degrees. So if I have this angle and I have this angle, then if I had this angle plus this plus y, that should give me 360 degrees because this is also a four-sided shape. 1, 2, 3, 4. This is also a quadrilateral. So if I had this plus this angle I got here plus y, that should give me 360 degrees. And that's what you are saying here, that the sum of all these angles will give us 360. Sum of angle in a quadrilateral. From there, you can find our y to be equal to what? 33 degrees. Then the last question we are going to talking is this one you are seeing on the screen right now. We have to find the value of our x given what you're having on the. So we are to solve this question. We are to find x given this angle to be 2s degree, this angle to be 60 degrees, and this angle to be s degrees. Now the solution of this one is very simple. Why? Because you can see that you're having a cyclic quadrilateral here. This is line 1, line 2, line 3, line 4. This is cyclic quadrilateral. And this angle here is an exterior angle to this cyclic quadrilateral. Also, this angle here, 60 degrees, also an exterior angle to this opposite interior angle rather. So this angle here is exterior angle to this opposite interior angle. So from there, that means the theory will prove that exterior angle of cyclic quadrilateral is equal to opposite interior angle. That means these two, which is interior angle, is equal to this opposite exterior angle, this angle here that is here. So that means these two s degree and this angle here are the same thing. So that means this angle here is going to be what? 2s degrees. Now we're having angle BCE. Where is BCE? This angle that is here is what? 2s degrees. Why? Exterior angle is equal to opposite interior angles of a cyclic quadrilateral. So from this triangle BCE now, if you have this angle to be 60 degrees, this angle to be 2s degrees, and this angle to be s degree. If you add all these three angles together, because this is a triangle, it should give us 180 degrees. Reason sum of angle in a triangle. And if that should be the case, what is 2s plus x? That will give us 3x. If I collect light time, take this 60 to the other side, we have 180 minus 60 degrees, that will give us 120. From there, I can divide both side by 3 to get my x, and my x is 40 degrees. That means the value of our x is 40 degrees. So that's the last question we'll be solving on this theorem. These two theorems I will just prove. And if you have not watched the previous videos on the solution of these two theorems, please go back to the two previous videos and watch other solution questions that we have solved. And On the screen right now, you're having two questions that you have to attempt on your own. If you have gone this through this training, yeah, you should be able to solve these two questions. The first one saying figure 1, you have to find angle EAD. Angle EAD. This is this angle that is here. And the second in figure 2, you have to find angle BXD. Angle BXD. That's it, this angle that is marked there, giving all these angles, this angle, 102 and 47 for this figure. So thank you for listening to this. Thank you for watching today's video. You are doing a great job, and we have been soliciting for help for those that love good things, and you have been following us since the beginning session of these channels for help to get some items so that you can take these channels to the next level. We have the mindset of helping the younger generations and understanding the concept on the mathematics, all the topics in mathematics, and please help us to subscribe to these channels, like the video, share the videos, and please do subscribe. It's very important to us, and as you do so, may the good Lord bless you. In the next video, we're talking about Monk theorem in circle geometry or circle theorem. So do have a wonderful day. Thank you for listening.
And in our last video, we talked about two theorems in circle geometry, whereby we talked about this opposite angle in the cyclic quadrilateral as supplementary. And we also talked about that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of that cyclic quadrilateral. And we use these two theorems to solve problems. But today's theorem, we are still on circle geometry or circle theorem. And today's theorem, we're going to talk about the theorem you can see on the screen right now that says a tangent to a circle is perpendicular to the radius drawn to its point of contact. A tangent to a circle is perpendicular to the radius drawn to its point of contact. What do we mean by a tangent? A tangent is a line that is drawn to touch a point on the circumference of a circle. That is, when you have a circle and you now have a line that is drawn, a straight line drawn to touch a point on the circumference of the circle, that means that line is a line of what? Tangent. As you can see on the screen right now, this line AB is a tangent because it's touching the circumference of the circle at point T here. So that means this line AB is a tangent. A tangent is a line that is touching the circumference of the circle at a point. So it's touching this circle at point T here. So what the theorem is saying that if there's a line that is drawn from the center of the circle that is perpendicular to that tangent, that means the angle between the line drawn from the center of the circle and the tangent is 90 degrees. That is, when you have a radius from the center of the circle and you now draw the radius to touch that tangent, you can see this radius here is touching this tangent AB at this point T. It's saying that the angle that exists between this radius and this tangent is 90 degrees. This angle here is 90 degrees. Also, this angle here is also 90 degrees, as you can see. So, as you can see, OTB is equal to OTA. That is the angle here. So, they are equal to 90 degrees. That's what the theorem is saying, that anytime you have a tangent to a circle, and there is now a radius drawn from the center of the circle that is perpendicular to that tangent, that means the angle between them is 90 degrees. That's what the theorem is talking about. I'm going to use it to solve problems very soon. Now, if you look at the slide, what you are seeing now on the screen right now, you can see that you're having a circle and you're having this line touching the circle at this point. So you can see that this line is a line of tangent. Also, you can see there's a line drawn from the center of the circle which is perpendicular to that tangent, and that line is a radius. So that means, from the theorem we just proved now, that means the angle that is here is 90 degrees. So if this angle here is 90 degrees and you have this angle here to be 72 degrees, you have to find angle X. You can see that this is a triangle now formed. So sum of angle in a triangle is going to be 180 degrees. And that's why you're having this 72 plus 90 degrees here plus X to give us 180 degrees. Sum of angle in a triangle. From there, 72 plus 90 degrees will give us 162 degrees plus X equals to 180. From there, you can find our X by removing 162 from 180. That will give us 18 degrees. That means this angle S here is 18 degrees.
Also, you can see on the screen right now that TA is a tangent at A. This line TA here, this line here is a tangent at A to a circle. So you can see that this line TA is touching this circle here at point A here. That means that line is a line of tangent. So AB is a chord. This line AB is a chord, and the angle BAT, angle BAT, that is this angle here is S degrees. We have to show that angle BOA is 2S degrees. Angle BOA, that is the angle that is here, is 2S degrees. You have to show that given what you are having on the screen right now. And if you look at the theorem we just proved now, that the total angle here, because this is a radius and this is a line of tangent, so therefore this radius is perpendicular to this tangent. That means total angle here is going to be 90 degrees. We just proved that theorem now. Now, if this total angle here is 90 degrees and we already have this angle here to be S degrees, then we can find this small angle inside this triangle. How do you find that? Since total angle here is 90 degrees, if you remove this S from 90 degrees, that will give us this angle here. So here you'll be having 90 minus X degree. So this angle is 90 minus. If our X, if the total angle here is 90 degrees from what we have just proved now, that means if this is S degree, that means you can find this angle here. This angle here, you can find this small angle that is here, and that will be 90 minus X. So if this is 90 minus X, we know that this BO is a radius and OA is also a radius. So that means this triangle here is an isosceles triangle, and base angle of an isosceles triangle are equal. That means this angle here is equal to this angle that is here. So if this is 90 minus S degree, that means this angle is also 90 minus S degree. So to get this angle here is by adding this plus this angle here and remove it from 180 degrees, because sum of angle in a triangle is 180 degrees. So if you add this plus this, remove it from 180 degrees, that will give us this angle that is here. And that is what you can see right here. So our angle BOA is equal to 180 degrees minus the sum of these two angles there. And the sum of those two angles here, 90 minus X plus 90 minus X. This 90 plus 90 will give us 180 degrees, and minus X will give us minus 2X. So if you use that bracket to open the bracket, you'll be having 180 minus 180 plus 2X. So, and if 180 minus 180 will give us 0. So BOA is 2X. That is, this angle inside there is 2X. Then if you look at this solution, this question that is giving, you have to find X, giving this angle to be 20 degrees. And if this angle is 20 degrees, you can see that this from this line to the center here is radius. From here to here also is a radius. So that made this triangle, this small triangle, an isosceles triangle as well. And this angle of an isosceles triangle are also equal. This angle here is also equal to this angle here. That means this angle here is 20 degrees. But from what you have been able to prove that if a radius is perpendicular to a tangent, that means this angle here is 90 degrees. So from the main triangle, this angle is 20, this angle here is 90 degrees, plus this angle, that will give us 180 degrees, sum of angle in a triangle. So that means the reason why you're having 20 plus 90 plus X to be equal to 180 degrees. From here, 20 plus 90 will give us 110. From here, you can find our X to be equal to 70 degrees. Also, from this one as well, we have to find our Y, given this angle here to be 62 degrees. So, but we know that this total angle here is going to be what? 90 degrees, because this radius here is perpendicular to the tangent here. So to get this angle here, that means you have 90 minus 62, and that will give us 28 degrees. So from also that, you can see that this is a radius, this is also a radius. That means this is an isosceles triangle. This angle here is equal to this angle here, base angle of an isosceles triangle. So if you add this plus this together, remove from 180, will give us our angle Y. And that's what we are having here as 124 degrees. Also from here as well, this is a radius perpendicular to this tangent. That means angle is 90 degrees. So if that should be the case now, this triangle is going to be a right angle triangle, because this angle is 90 degrees. So our aim is to find our line OA here, which you can use Pythagoras theorem to find, is given this side and this side. So if you use your Pythagoras theorem, square of the hypotenuse sides equals to the sum of the square of the remaining two sides. That's what you're having here. So from here you can find our A hole to be 15 centimeters. So that's the solution. What we have been able to use that theorem to solve all these questions. So in our next video, we're going to talk about the next theorem, and I'm going to use it to solve problem as well. Please do share our videos, like our videos, subscribe to our channels. So we'll be helping students to know better all this circle geometry. And another of all the theorem, we're going to be solving why question. And I hope you have been able to learn one or two things from this video. Thank you for listening.
I want to welcome you to today's teaching. And in today's teaching, we'll be talking about another theorem in circle geometry. And that will be the last theorem we are going to discuss on this circle geometry. And the next in the couple of videos we are going to make now, we'll be solving extensively on circle geometry using all the theorems that we have discussed so far. In this theorem now, we are going to make you talk about angle in alternate segments. Angle in alternate segment. When do we have segments in a circle? That's the question we need to ask ourselves. When do we have segments in a circle? Now, when you have a chord inside a circle now, segment is formed. When you have a chord drawn in a circle now, segment is formed. So you can see this line is a chord. So this space here you're having here that is colored is a segment. Also, this white one is also a segment. So when you have a chord inside the circle, that means a segment is formed. Also, if you look at what you're having here right now, you are seeing that this another chord here inside this circle. That means this side is also a segment, and this also a segment. And we have minor segment, we have major segment. This one here is the major segment because it's bigger than this other one. So look at the second one. This also is a minor segment because this one is smaller compared to this one. So this is major, this is minor. So having known what a segment is, that will help us to talk about the next theorem we're going to talk about. And that the theorem is talking about the angle in the alternate segment are equal. Angles in alternate segment are equal. Now, if you look at this line here, this line is ECBD. This line here, we talked about this line in the last theorem we proved that this line is a line of tangent because it's touching the circumference of the circle at this point. So that means this line here, line ECD line ED is a tangent to this circle at point C here. So when you draw a line of tangent to a circle, as you can see, and you now draw a chord inside the circle and the chord is touching the tangent at a point here. Now, if you look at this line, this is a chord. Then that means this side, this point, this position here, this space here is a segment. And also everything you have here is also a segment. This is a minor segment here, and this is a major segment here. So if you have a line of tangents and a chord is drawn in the circle and it's touching that tangent, that means the angle that is formed here, the angle that is formed here in this segment is alternate to this angle here that is here. And look at how do we get this angle here. Look at this chord that is drawn here. And look at this another chord joined to it. This another chord joined to that this chord. And another chord joined to this chord here at this place as well. So where these two chords, this chord AB and this chord AC meet, that is joined to this chord you are talking about, that's where the angle will be. So you can see that this angle here is alternate to this angle. Also, this line here is also a chord. This line AC is a chord, and it's touching this tangent as well at the circumference here. So also that means this angle here, your angle here, you can see on the screen now, is alternate to another angle. It's alternate to another angle. So you can see that this side also is a segment. So that means this portion also is everything here also is a segment as well. So since this chord here is touching this tangent here, so that means angle here is also alternate to this angle that is here. And that's what we are going to see in the next and that we are seeing here right now, that this chord here QX is alternate. The angle that is formed here with this tangent is alternate to this angle here as here, because if you look at the tangent, this chord here SQ here, and this is another chord drawn to it, touching it, and another chord touching it. Where these two chords meet, that's where the angle is going to be. So that means this angle here is alternate to this angle, and that's why you're having that PQX is equal to SYQ. So you're going to be using this theorem to solve problem in the next in this video. Now, the first one you're solving is the one you are seeing on the board now. In the figure below, PQS is tangent to circle QRS. PQS, this line here is a tangent to this circle. Now,
calculate SQS. SQX. That means this angle that is here. You have to calculate this angle that is here. So, and you can see this, since this is a chord, SD is a chord, and it's touching this tangent. That means there's an angle is formed here, and that angle will have a relationship with this angle that is here. This angle that is here and this angle here, they have relationship because this chord. So there's a relationship between this angle SQX that we have to find and this angle here, angle SRQ, this angle here. If you look at this line SQ, this line SQ is touching this tangent. So that means this angle here is alternate to this angle. That's what it implies with the law, with the theorem we just proved now. So, and if that should be the case now, this is a triangle now. We can find this third angle by saying this angle plus this angle plus this angle here will give us 180 degrees, sum of angle in a triangle. Then from there you can find this angle SRQ, which is going to be this plus this, and that give us 103 degrees. If you remove it from 180, that will give us 77. So this angle is 77 degrees, and that means this angle SQS you have to find is also 77 degrees. Reason this angle here is alternate to this angle. Another thing is that this angle here also is also alternate to this angle, 55 degrees. If you have to find that, you should know how to get that. In the next question here, you are in the figure below, PT is a tangent to circle. This line PT is a tangent to this circle, and you are told that BA is equal to BT. These are BA. This line BA is equal to BT. That's why you're having two stripes, this stripe and this stripe on it. So that made this triangle BAT. This triangle here, an isosceles triangle, because two sides are equal. Then you are told that angle ATP, angle ATP, this angle here is 82 degrees. You have to calculate BCT. This angle that is marked here, you have to calculate that. And how do we do that? You can see that there is a relation between this angle, 82 degrees, and this angle that is here. Look at the chord. This is the chord that is joined to this tangent, and this is the line, and this line is joined to this chord. So that means where those two lines meet, this angle is an angle is going to be formed there, which is alternate to this angle. So if this angle here is 82 alternate angle, then this isosceles triangle, base angle of isosceles triangle are equal. Base angle of an isosceles triangle are equal. That means this angle here and this angle here, they are equal. So if I can remove this angle here from 180 degrees, then divide the answer by 2 will give me this angle and this angle that is here because they are equal. And that's what we're having here, that our angle this angle here, they are, and this angle here, they are both equal. So if I remove this 82 from 180 degrees, then divide the answer by 2 will give me 49. That means this angle here is 49 and this angle here is 49. So angle BAT is 49. Now if you look at this line BA, this line, and this line, we have four-sided plane shape there. That is exactly quadrilateral. Since you're having this four-sided shape inside the circle, that is exactly quadrilateral. And this we have proved in the previous video that opposite angle in quadrilaterals are supplementary. That means this angle here and this angle here will be added up to 180 degrees. So if this angle is 49, then if you remove it from 180, we get this angle that we are looking for. And that we are having here that BCT plus 49 degrees equals 180 degrees. And from there, you can find our BC to be equal to 131 degrees. Then also, if you look at this question on the screen as well, we are told that the TS is a tangent. This TS is a tangent to this circle. Then if PR is equal to PS, PR is equal to PS, and now we are having this line and this line on them. We are told that angle PQR, angle PQR, this angle here is 117 degrees. You have to calculate angle RST, and that's why this one is marked. You have to find that angle. So what's the solution to that? You can see that this line, and this line, this is a four-sided plane shape inside a circle. That means that's exactly quadrilateral. So this angle here and the angle here, this one here, they are supplementary. So if you remove this from 180 degrees, that will give us this angle that is here, supplementary angle. And now you're having this angle to be 63 degrees. So this triangle here, triangle PRS, is an isosceles triangle because this side is equal to this side. So that means the base angle are equal, this angle here and this angle. So if this is 63 degree, that means this side is also 63 degree. Add this together, then remove it from 180, that will give us this angle that is here. That's why you are having this angle to be 63 plus 63 plus this angle RPS equals 180 degrees. Sum of angle in a triangle. Then 60 plus 3 will give us 126. 126 minus 180 will give us this angle here, and that's 54. So this angle here and this angle here, they are alternate angle from what you have just proved. That this is a chord, and this line is joined to that chord. So that means this angle. In this video, we are going to be solving examination question using the circle geometry. We have the theorem we have talked about in circle geometry. You have talked about some theorems in circle geometry, and if you have not watched the videos on those video, please don't watch this video because you might not understand. Please, you have to go back to the videos where we prove all the theorems, and we use them to solve some problems, simple problems, before you can now come to this examination question. And if you look at this in this question, we are told that in the diagram ABCD is a cyclic quadrilateral. Now this is a circle now, and we have justified in the previous video that anytime we have a quadrilateral inscribed inside a circle, that is a four-sided plane shape that is inscribed inside a circle. That means that's a cyclic quadrilateral. So it means that this circle here is a cyclic quadrilateral, because if you look at this line AD, then line DC, line BC, and line AB, that's a quadrilateral that is inscribed inside the circle. You are told that this AB is produced to P, and line DC is also produced to P. You're also told that line AD is produced to Q, and line BC is also produced to Q. Then if angle DQC, angle DQ, then C is 76 degrees, then our angle BPC, BP, then C is 52 degrees. Then our angle BCP is S degrees. You have to calculate the value of this X. Now, if you look at this question very well, you can use the theorem of cyclic quadrilateral, the theorem that we talk about in cyclic quadrilateral, that says that opposite angles of cyclic quadrilaterals are supplementary one, and also the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of a cyclic quadrilateral. So that can be used to solve this question. Our aim is to find this angle X, what it represents. And if you look at it, this angle X here and this angle A here, they have relationship, because this angle S here is the exterior angle to this angle A. So that means exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So that means this angle DAB is X degrees. And that's what you're having here, that exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Also, if you look at it very well, this is a triangle CBP. Triangle CBP, this small triangle that is here. This angle plus this angle here will give us this angle here. Reason, the exterior angle of a triangle is equal to the sum of the two opposite interior angle. We have said that in the previous video, that the addition of this angle S plus 52 will give us this angle here. And that's what you are having, that our angle ABC, this angle that is here, is the addition of this angle and this angle. So if that should be the case, we have gotten this angle as X, this angle as S plus 52, and we are having this angle as 76. This is a triangle now. Triangle AQB is a triangle. So the addition of all these three angles, this angle here and this angle here and this angle here, should give us 180 degrees. And that's what we are having here, that the sum of the angle in a triangle is 180 degrees. So from there, if you sum it together, we have S plus L plus 52 plus 76 equals 180 degrees. S plus L will give us 2x. 52 plus 76 will give us 128 equals 180 degrees. From there, you can find your 2x, which is going to be 180 minus 128. And 2x is going to be 52. From there, you can divide both sides by 2. That will give us 26 degrees. So that means our angle S here is 26 degrees. The question is very simple, and that is the WAEC 2015 question number 9 given to them. You can cross-check it in your past questions, and you will see that this is a wonderful question. So that's the solution to that question. and it's very, very simple. And there are other methods in which you can use to solve that question as well. You can get this angle, which is vertically opposite to this angle, and there are other methods in which you can solve it, but this is the simplest method we can use to solve that question. Mr. Adebanjo. And today also we are going to solve another examination question. But before we solve that question, we are going to need this plane geometry to solve that question. The understanding of plane geometry will help you to solve that question. Now, there's going to be there's going to be a full video on plane geometry very soon. We're going to do, but let's just briefly talk about this now. When you have two parallel lines, and there's a line that cut across those two parallel lines. That line is called line of transversal. So odd angles are formed. Different angles are formed. But the one that I need today in this to solve this question is the opposite in some of the two opposite angles is equal to opposite interior angle is equal to 180 degrees. Opposite interior angle of this is equal to 180 degrees. That is this angle C here and angle D here, they are interior angles. So the addition of this and this will give us 180. The addition of angle F and angle D also will give us 180 degrees because they are opposite interior angles. So we are going to use that to solve this question now. If you look at the question says that in the diagram below, TS is a tangent. TS is a tangent to the circle at A, and AB is parallel to CE. Line AB is parallel to CE. That's why you're having arrows on them. Then angle AEC is 5s degrees. This angle here is 5s degrees. And angle ADB, A, then D, then B. This angle here is 60 degrees. You have to calculate angle TAE, angle TA, then E. This angle marks X that you have to find. So, okay, we are giving angle TAE as X degree rather. So we have to find the value of X. So if that should be the case now, you can see that this circle here is a cyclic quadrilateral one. This line and this line is a quadrilateral inscribed inside the circle. That's a cyclic quadrilateral, but that's not the all. This is a tangent TA, and if you look at tangent TA, this line here, this line AE is a chord. Line AE is a chord. If that should be the case now, also if you look at this line AB is also a chord. So, and that chord is touching this tangent. Also, this line A is also a chord touching this tangent. So that means there's going to be relationship. If you look at this chord AB now, there's going to be relationship between this angle here, this angle SAB, this angle that is here, small angle that is here. There's a relation between this angle and the angle 60 that is here. Because if you look at this chord very well, this line is joined to it that is at D here, and this line is also joined to it at D here. So that means this angle 60 here is going to be equal to this angle here. Reason being that alternate angle, as you can see, alternate angle. We talk about theorem that says alternate segment rather. Alternate angle in alternate segment are equal. Angle in alternate segment are equal. That is, this angle here is alternate is equal to this angle in alternate segments. So this angle is 60 degrees. This one is also 60 degrees. So if that should be the case now, if you look at this parallel line, this line is parallel to this parallel line. That means this line AE is a line of transversal to these two parallel lines. So that means this angle 5x and the angle that is here, total angle that is here, joined to this parallel line, this angle that is here, the addition of them will give us 180 degrees. Reason that's what I show you in the first diagram now, that opposite interior angle are supplementary. That this angle here we had plus this angle here will give us 180 degrees. So to get this angle here, if you remove this 5x from 180 degrees, that gives us 180 minus 5x. So that's why this angle BAE is 180 minus 5x. So if I have angle BAE to be 180 minus 5x and this angle here to be 60 degrees, so total angle on this straight line will give us 180 degrees. Reason angle on a straight line. So the addition of this angle x plus 180 minus x plus 60 will give us 180, and that's what you're having on the screen right now. That this is angle on a straight line 180 degrees. So if you sum this plus this, that give us 240 minus this minus 5x plus 7 will give us minus 4x equals to 180. Then collect like terms, minus 4 equals to 180 minus 240, that give us minus 60. Then minus 4s equals to minus 60, s will equal to 15 degrees. So our s is 15 degrees from the question. The question is very simple. This angle here is equal to this angle here, angle in the alternate segment. So today we are going to solve this question, this examination question as well. And this is the third examination question we are solving using circle geometry that we have learned so far, all the theorem that we have learned so far. We are just making use all the theorem now to solve any question that comes our way. And all these questions, this is the third question we are going to be solving now. That is examination question. If you look at the question in the diagram, TU is a tangent to a circle. This TU is a tangent because it's touching the circumference of the circle at this point, U. So it's a tangent. So angle RU, angle RVU, RV then U is 100 degrees. And angle URS is 36 degrees. This angle is 36 degrees. You have to calculate the value of angle STU. Angle ST then U. This angle that is here, that's what we have to calculate. And I'll go by this. Now, you can see that this circle here is a cyclic quadrilateral. Why? Because the four-sided plane shape is inscribed into the circle. So this side VR, side VU, side US, side RS is inside the circle. So that means a cyclic quadrilateral. So this angle here is going to be equal to this angle here. You should know the reason now. If you have been following the proving that we have done in circle geometry on cyclic quadrilateral, you know that this angle UST is going to be equal to this angle 100. The reason being that exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. This is an exterior angle to this cyclic quadrilateral, so it's going to be equal to this angle here. So that means this angle here is going to be 100 degrees. Also, since this line here is a line of tangents, and this line here, this line US is a chord, and it's touching this tangent at this point. So if you look at this line, this chord US, look at this chord that is joined to it. This UR is joined to this chord, and this chord SR is also joined to this chord. They now meet at this R here. So that means the angle E that is formed here, 36, is going to be in alternate segment to this angle here that is here. Don't forget, we're talking about angle in alternate segment, that they are equal. So this angle, the angle that is here, this angle SUT, the angle that is here, total angle that is here, is going to be equal to 36 degrees. Reason alternate what? Angle in alternate segments. So if this angle here is 36 degrees, and you have justified that this angle here is 100 degrees, so the addition of this angle here and this angle here and the angle we are looking for will give us what? 180 degrees. Reason, sum of angle in a triangle. This triangle SUT is a triangle. So if you add all the three angles together, it should give us 100. And that's why you are having 100 plus 36 plus angle STU is equal to 180 degrees. Sum of angle in a triangle. From there, this plus this will give us 136. Then, if you subtract 136 from 180 degrees, that will give us STU, which is going to be what? 44 degrees. This is the third question, and this is a YI 2012, question number 3 here. More examination question is still coming, more in the video I'm going to draw very soon. So do like our videos, subscribe to the channels, share the videos to your friends in another school, and
learned so far in circle geometry to solve this problem. So it means that if you have not watched the video on where we made the explanation on all the theorems that are in circle geometry, that means you are not meant to watch this video. You are not entitled to watch these videos. So you have to go back and watch those videos before you can now solve this problem. Because if you don't understand the theorems and how to use them, you might not be able to understand this question we want to solve now. Please go back to the videos that we have made in the past on how we explain all the theorems and how to use them. Now, if you look at the question we're having on the screen right now, we are having that the diagram shows a circle PQRS. PQRS, this is a circle with center O, and angle UQR is 68 degrees, this angle that is here, and angle TPS is 74 degrees, and angle QSR, this angle is 40 degrees. You are asked to calculate the value of angle P R PRS. PRS. This angle that is there, this small angle that is here, you have to find. So using this information given to us in this circle geometry. Now, how do we go about that? If you look at line PS, sorry, line PQ rather, this PQ here, this line PQ here, then line QR, line RS, line PS. So that this is quadrilateral inscribed into a circle. So that's a quadrilateral inscribed into a circle. So that means this circle is a cyclic quadrilateral. It's a cyclic quadrilateral. So, and then in cyclic quadrilateral, we have two theorems under it, whereby we said that opposite interior angles of cyclic quadrilateral are supplementary, that is, they add up to 180 degrees. And we also said that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of that cyclic quadrilateral. The exterior angle is equal to opposite interior angle. So if that should be the case now, if you can see that this angle 60 is an exterior angle to that cyclic quadrilateral, which is equal to the total angle that we are having here in S here, the total angle there is equal to 68 degrees. And that we are having there that angle PSR is equal to 68 degrees. And the reason being that the exterior angle of cyclic quadrilateral is equal to the opposite interior angle. So if this total angle here is 68 degrees and we have been given this one as 40, that we can find this angle that is here. So that will give us 68 minus 40 degrees, and that will give us 28 degrees. And that's what we are having here, that the angle angle PSQ is 28 degrees. If that should be the case as well, we also know that this angle here, PSQ, we just found, and this angle that is here, this one, they have relationship. And what's the relationship? They are in the same segment. We also talk about another theorem saying that angle is in the same segment are equal. So this angle here is equal to this angle that is here, 28 degrees. So if this angle here is 28 degrees, now our aim is to find this angle from the question. Then if you look at this exterior angle of this cyclic quadrilateral, this 72 degrees is equal to the opposite interior angle. That's the total angle that is here. Total angle that is here is equal to 72 degrees. And we have already gotten this angle as 28 degrees. So therefore, if you remove 28 degrees from 72 degrees, and that will give us this angle that we are looking for, this PRS that we are looking for. And that's what we are having here, that 74 equals to 20 plus PRS, angle PRS that we are looking for. Then to get PRS, if you remove it from 28 from 74, and that will give us this angle that we are looking for, which is 46 degrees. And that's the solution to that question.